Hello and welcome, coming to you once again, not quite live from One Take Studios. Today's topic is solving multi-step inequalities. Multi-step inequalities. I almost said the word equations because, solving inequalities again is very similar to solving equations. So if you can solve equations, there's very little adaptation that has to be done in order to solve inequalities. So what is the difference? Dun 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 dun. If you don't have this written someplace at least once or twice or three times, you should write it again. Ladies and gentlemen, this one thing is what separates solving equations from inequalities. Because it's greater than or less than, or greater than or equal to, less than or equal to. If in the process of solving, you multiply or divide by a negative number, you have to flip the inequality sign. All right, it changes the balance of the equation, and so if you flip the inequality from greater than to less than, and so on and so forth, that changes and adapts to make sure that you still have a true statement when you are done. So again, it has to be multiplication, division by a negative number, not just with a negative number, but by a negative number. I keep reiterating this, and I will show you in our examples what I mean by that. Our questions that we use to focus ourselves for solving equations, again, will also work for solving inequalities. Asking ourselves things like, where is the variable? Because again, our goal is to get the variable by itself, so first we want to find the variable, and then say, what is with the variable? What numbers are surrounding it? How is it attached to the variable? So how are these numbers attached to our variable, and how do we break that attachment? How do we undo it to get the variable by itself? So keep those things in mind, and I'm going to run you through a couple of examples just to make sure that we are all on the same page. In this case, literally, this page right here. All right. So for examples, I'm starting with 2x plus 1 is greater than 11. Where is the variable? Boom, right there. What's with the variable? The 2 and the 1 are both on the same side of the inequality. How is the 2 attached? Through multiplication. How is the 1 attached? Through addition. How do I break those attachments? Well, this is multiplication. I'm going to need to divide. And this is addition. I'm going to need to subtract to undo it and to get rid of it. Does it matter which one I do first? Yes, actually it does. All right. If we think about this the same way that we think about unwrapping Christmas gifts, however the gift got into the box, we need to undo everything in reverse to get the gift out. So this is our gift. We're trying to unwrap it. We're trying to get rid of everything around it. So order of operations says that we would do multiplication first and then addition. If we're going to unwrap that or undo that, the addition, which is the last thing in order of operations, is the first thing that we are going to undo. So we want to subtract 1 to undo the plus 1. But again, we're going to do the same thing on both sides to make sure that that happens. All right, these guys go away. I'm left with my 2x, yay me. This is still greater than, and 11 minus 1 is 10. All right, this is multi-step, so that was one step. We've got one more step in this case to again continue to get this variable by itself. We said the 2 is attached through multiplication. We will need to divide by 2 to undo that. But again, same thing on both sides. Keep the balance. Dividing by 2. There is the x by itself, yay us. There is the greater than sign, and 10 divided by 2 is 5. Okay? We subtracted 1, we divided by 2. At no point did we multiply or divide by a negative number. We divided by a positive 2, but that's okay. We didn't need to change this. Pick a number bigger than 5. If you don't believe me, a number bigger than 5. X is bigger than 5. Let's go with 6. 2 times 6 is 12, plus 1 is 13. Is 13 bigger than 11, greater than 11? Yes. All right, so this is going to be good. Can you graph? We haven't done graphing in a little while. Let's see. What might my graph look like? Do I have to have 0 on my number line? No. Could I have 0 on my number line? Yes. Maybe I decide I'm just going to put 5 in the middle because I know I need 5. And I can go 6 and 7 and 8 if I want to, and I can count down, and there's 4 and there's 3. All right, as long as I have consistent counting on my number line, I can start and end wherever because the arrows on both ends will say that I keep going. How do I graph x's that are bigger than 5, greater than 5? Open circle or closed circle, again, it's been a while. I do not want things that are equal to 5. So I want to indicate 5 as a starting point, as a boundary, but I don't want to actually include the 5. So if I do an open circle, that means I'm going to start at 5, but I don't want to have it equal to 5. I'm just starting there. And then greater than 5, numbers that are bigger than 5, 6, 7, 8, that's all of these guys right there. So there we go. That is my answer, ta-dun, ta-dun, and that is my graph, greater than 5. All right, let's run another one. I'm trying to give you a wide variety of things that might happen with this. So here's our second example, which, if you notice, does not look like the first example. I might do this just to make sure that we don't get confused. Okay, that's one example. This is a different example. Here we go. Okay, so 4 plus x over 3 is less than negative 4. What am I going to do with this mess? Yikes. Well, let's see here. Again, here's my x. I've got a plus 4. I've got a divided by 3. I need to undo both of those things. It's kind of weird that when I have a giant division bar like this, that actually indicates a grouping operation. This means that these guys go together and that the divided by 3 would come last. And so since the divided by 3 comes last, it's the first thing that we want to undo. All right, that means how do I undo a divided by 3? With a times 3 here and a times 3 here. Again, doing the same thing on both sides. Times 3 undoes a divided by 3, leaving me with the 4 plus x. This is still less than, and this is still negative. Oops, no, it's not still negative 4. Excuse me. Negative 4 times 3 is negative 12. There we go. That's what I want to say. Should I have flipped the inequality sign? I did multiply. There is a negative. But did I multiply by a negative number? I multiplied by a positive 3. Again, I did not multiply by a negative. I'm going to leave that as is. I have one more step for getting that x by itself. That's attached through addition. We'll do a minus 4 to undo the 4 that's been added. Again, we need to do the same thing on both sides. Going, gone. And x is now less than, negative 12 minus 4. I owe $12. I owe $4 more. Now I owe a grand total of $16. That should be my answer. X is less than negative 16. Again, if I pick something, I can probably make this to be true. Let's make sure I go with, sorry, my brain is not working. All right, real quick. Let's just go with, let's see, something that is less than negative 16. What's smaller than negative 16? Maybe I go with negative 20. Okay, so negative 20. What is 4 plus negative 20? 4 plus negative 20, that'd be negative 16 divided by 3. Negative 16 divided by 3, that's going to be 5 and a third, right? Yeah, I think so. If not, I apologize. My brain is not entirely working today. But that is a value definitely smaller than negative 4. Again, I'm just doing a quick little test to make sure that I have this correct. And I do. All right, if I'm going to set this up and graph it, again, think about what's got to be on my number line. I know the negative 16's got to be there, so maybe I just throw the negative 16 in the middle, because quite frankly, I don't want to count from 0 all the way down to 16. That sounds like a lot of work. Ooh, if I was going to count up from negative 16, what would that be? This would be, what's bigger than negative 16? Negative 15, negative 14, negative 13. Kind of squish those in there. What goes this way? Oh, again with the squishing. This would be a negative 17, negative 18, and so on and so forth. All right, so as I go to the right, the numbers get bigger, closer to 0. And as I go to the left, the numbers get smaller, farther away from 0. All right, this is x is less than 16. I want things that are smaller than 16. Again, do I want an open or closed circle? This was greater than, but not equal to. This is less than, but not equal to. That means this is just my starting point. I don't actually want to include it. I just want to say that's my starting point. And then less than, it's going to be everything that is below the negative 16, and that would be my graph. Okie dokie. All right, 2 more. I want to go through 2 more examples, because I think that your brain should take a look at these things. Again, a little bit different. Each problem's a little bit different, and you have to be kind of flexible with your brain, all right? By the way, did you write these down? Because you're probably going to want to have good examples to look at, to compare. Again, keeping these questions in mind helps, but sometimes a good example is just really useful. Okay, so let's see what we've got here for this one. Here's my x. It's got a -2 attached to it. That's multiplication, and a 4 attached through addition. So I'm trying to break those attachments, undo them. Again, the last thing in order of operations is plus. That's the first thing I want to undo. So -4, gone, 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 boom. 6 minus 4 is 2, is now less than or equal to -2 times x. And because that's -2 times x, to undo it, I need to divide by -2 and divide by -2. Wait a minute, did you just hear the words that came out of my mouth? I said I'm going to divide by -2. Divide by -2. Ding, 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 ding. Are you paying attention? Because right here, this is going to be interesting. All right, 2 divided by -2 is -1. Here, the -2's cancel. There's my x by itself. But because I divided by a -2, I don't want to say less than or equal to. I now want to say greater than or equal to. Greater than or equal to. All right, this makes all the difference in the world. This means that, notice also the x is on the right side instead of the left side. So the x is on the tiny side of things, and the -1 is on the big side of things. So I want things that are actually smaller than -1, because -1 is greater than x. So pick something smaller than -1. Maybe we go with -4. No, -5. I'm going to go with -5. So -2 times -5, that's going to be a positive 10. 10 plus 4 is 14. Is 6 less than or equal to 14? Yes. Why did I do that? I'm just doing a quick check to make sure I'm in a good place. I did turn the inequality over. I was supposed to. Yay me. What do I do with the graph of this thing? Maybe I'm going to slide the graph over here for the moment. Let's do that. I like that idea. Again, I know that -1 needs to be in my graph, so might I have 0 on this graph? Oh yeah. Do I have to have 0? No, but that makes sense for this graph at least. And there's 1, and there's 2, and there's -2, and obviously this graph keeps going at both ends because it is a number line. All right, graphing. Do I want an open or closed circle? Notice this says greater than or equal to. This says I want to include the -1 as part of my answer. How do I include it? Closed circle, saying that this part right here is shaded in. This is part of my answer. So the question becomes, where does the rest of my shading go? Again, the x's are on the small side of things, and the -1 is on the big side. So -1 is greater than x. So that means the x's are smaller. They are over here on the left. So even though that says greater than, because the x is sitting here, this is actually where the rest of my answers are going to be. All right, last one. One more, I promise, right here. Alright, so we've got a -21 is greater than or equal to -3 times x plus 4. Again, I'm just going to kind of do a separating line here on the page to make sure that we understand what's happening. Ooh, parentheses. This reminds me of something called, oh yes, the distributive property, which is kind of like launching water balloons. Right there. I'm doing -3 times the x and -3 times the 4. Is this the only way to approach this problem? No, but this is probably the one that a lot of people's brains are going to go to. What is -3 times x? -3x. What is -3 times positive 4? That's going to be a -12. And again, I just continue with, here's my x, how do I get it by itself? The -3 is attached, the -12 is attached. Well, let's see. Again, the last thing for order of operations is going to be subtracting, so it's the first thing I'm going to undo. I'm almost always undoing my addition subtraction first. There are weird cases, of course. That's going to undo that. -21 plus 12 should be a -9. -9. Do I like that? Does that make sense? I think that does. Yes, I agree with myself. Great. Okay, and that's going to be greater than or equal to, and then I've got my -3x. Notice I added 12, so I'm not flipping this over. But what's going to happen next to get the x by itself? I'm dividing by and dividing by a -3, dividing by a -3. Ladies and gentlemen, ding, ding, ding. Are you on the alert right now? And why does that look like a 2 instead of a 3? All right, must always be paying attention because this guy here does not announce itself. That's going to undo the multiplication. -9 divided by -3. Negative divided by negative is a positive 3. There's my x by itself. Because I divided by a negative, I need to flip this over. Boom and boom. Okay. All right, so that is going to be it. Again, you can pick a number that has x being bigger than 3. You can plug it in and check it, but this is going to be good for us here. Graphing. Let's see, we know we need a 3, so maybe we go with a 4 and a 5. 4, 5, 6, just for the fun of it. 2, 1. Do I need to put in 0? No. Can I put in 0 if I want to? Yes. Graphing, open or closed. Do I want to include the 3 or equal to? Or equal to means yes, absolutely, I would like to include the 3. So closed circle, we are shading this in, saying we want to include this as part of our answer. Left or right, which way should we go? Again, notice the x is on the right side here. It's on the big side. The x's are bigger, the 3 is small. This says 3 is less than x. That means I want the things that are bigger than 3. And that's going to go this way right here. All right? So there's a whole bunch of detail to pay attention to as far as, do I want an open circle? Do I want a closed circle? Do I want to shade to the left? Do I want to shade to the right? Do I need to turn over and flip my inequality sign or not? Please be aware. To the best of your ability, be aware. Keep these things in your brain because, again, they do not announce themselves and you have to be thinking all the time. Having good examples can help. And, yeah, all right. Try, practice. Practice will make you better. Make sure that you got somebody checking in on you, though. All right? Thanks. Bye. Have fun.